Now this illustration deals with methods of grounding and bonding conductor connections to electrodes. Inner coordinates is outlined in 250.70. I have seen where a grounding electrode conductor was connected to a concrete encased electrode, and the number 4 was just laid on the rebar and it was tie wrapped to it. I've seen some unusual connections, is what I'm trying to say, when I was in inspection. And I'm sure electricians and inspectors, as well as engineers, have seen this kind of thing if they've really made the inspection. Now, notice I really like the grounding loop. I think it's a good one. If you look at the grounding loop, the grounding electrode conductor material is found in 250.62. So you can just go there and see what the material could be used, like copper, aluminum, copper clad, that kind of thing. Installation rules is 250.64A is an apple through D. You can find your installation rules. Enclosures to protect your grounding electrode conductor, 250.64E. Sizing the grounding electrode conductor to connect a structural steel or water pipe, table 250.66. But to individual electrodes such as driven rods, a concrete encased electrode, a ground ring, is found in 250.66, A through C. The connection of the grounding electrode conductors, 250.68, and now the fittings that are allowed, which we're talking about, is 250.71 through 4. And that is an area that I found a lot of mistakes made. So what this section 250.71 through 4 is pointing out the correct way to make the connection of the grounding electrode conductor to a grounding electrode. Now, notice the fittings and the call out to the right, 250.70. The metal water pipe, if it is not an electrode, 250.104A. In other words, 10 feet or more if it's not in the earth. If it is an electrode, remember 250.52A1, 10 feet or more if it is in the earth of a metal water pipe. Then 250.64E deals when it is accessible, when it does not have to be accessible, the connection. Does it have to be made within 5 foot where it enters the building or anywhere? We'll find that in 250.64E. The bonding jumper now is 250.94. So, for example, if we use the metal conduit to enclose and protect that grounding electrode conductor at some distance, is shown in the illustration, it has to be bonded on each end, as you see. And it has to be the same size as the grounding electrode conductor. So again, if we had, say, 250 kc mill terminating in a main in that panel board, then table 250.66 would require a number 2 to connect to the grounding electrode, such as a metal water pipe. Then to enclose that grounding electrode conductor is shown in that illustration with, say, a metal enclosure, such as rigid metal conduit, say. Then it has to be bonded on each end, and it'd be number 2, as you see there, to number 2 grounding electrode conductor. Now to the left, you see a driven rod. 250.52A5 says it has to be 8 foot in length, 8 foot below the grade. 250.53G gives you installation rules. 8 foot in the ground, angle no more than 45 degrees, trenched. It goes through the procedure. Then the next is the structural steel. 250.104C says, no, it's not an electrode because it's not bonded and grounded in to an electrode system. 250.52A is an apple 2 says, yes, it is. 10 feet or more is a beam in the earth or it's connected to the concrete encased electrode, it's connected to a water pipe that is an electrode, but it's bonded in by 250.52A2. Now, that's what this figure 16-90 is illustrating, how you make the appropriate connection of the grounding electrode conductor to an electrode, such as a driven rod, steel, or maybe a water pipe or enclosure and so forth. It gives you 250.70, 1 through 4, with fittings and things that are permissible to be used, and the authority having jurisdiction will accept without a problem. Anything else would have to be approved by the authority having jurisdiction, and they're not apt to approve anything that's not in 250.70 as a rule. So keep this in mind, what this illustration 16-90 is illustrating.